Hello, everybody. Welcome to today's webinar, Valve Guides, Iron versus Powdered Metal. I am Amanda Harmoning, and I am an admin assistant here at AERA. I will be moderating today's event. And joining me from AERA is Rob Monroe.
Hello, everyone. Like Amanda mentioned, my name is Rob Monroe. I look after membership and technical development here at AERA. So just a couple quick housekeeping slides here before we get started. I know a lot of you have been on our webinars before, but for some of you that haven't, AERA, if you're not sure who we are, we've been around since 1922, so we've been around a very long time. We're a nonprofit association. Our main goal here at AERA, we supply member shops with technical information and specifications. We have 4 techs, including myself, that are on the tech line. We're open 7 a.m. to 6 p.m. Central Time, and we're Monday through Friday. So we'd encourage all of you that have shops to, allow us to do all of your engine lookups for you. You're probably better off on the shop floor making money, so let us do all of that research, and that's what you have membership for. So take advantage of that tech line, and that's what you've got it for. So here's another good reason to be a member is our Engine Rebuilders Educational Foundation Grant Money Program. So if some of you are maybe thinking about attending one of our tech and skills conferences, or maybe you're looking at enhancing your skills by taking an engine related course of some sort, there is monies available through our grant program through the EREF for you to take advantage of. So as a member, just go ahead and contact us. We'll send you that information on how you can apply. And again, use that towards furthering your education and enhancing your skills. So it's money's there for you to use. All right, well, let's get on with the presentation today. So now he's Chuck Lynch. He's with Mala Aftermarket. And a lot of you might remember, Chuck was on the tech line here at AERA for several years. So we're really excited to have him. He's now a PER sales engineer for Mala. And again, we're excited to have him back to do the presentation for us today. So, hey, Chuck, how's it going, man?
Going great, Rob. Good to be back on board here. First off, I'd like to say good day to everyone. I know we have people from every time zone potentially online, so we'll say good day rather than good morning or afternoon. And we'll get started with the presentation. All right, so today the topic is going to be valve guides, PM versus cast iron. A little bit about myself, Chuck Lynch, I'm PER sales engineer from Mala. Been in the industry nearly 30 years, served as a technical specialist for AER prior to joining Mala, of course. And in my current capacity, I serve as kind of a technical liaison between our product groups and support the area sales agents, as the PERs are, not in just one area of the U.S., as we all understand. So anyway, that's kind of my capacity at this time. Okay, so just on this presentation today, we want to really just look at this from like a 30,000 foot view of the subject. There's a tremendous amount of information that could be covered, and we just don't really have the time for that. So what we can do is kind of get the juices flowing and come back with some more specific topic matter once we've kind of gone through this from a high level view. So the subject that I have been involved with recently, as I have some history with machine tool companies, again, being a PER, and actually the tooling manufacturers as well. We've really talked about the challenges of powdered metal and how we address those, what's the best way forward. So valve guide in general. So it's often an underappreciated component. A valve guide has very important tasks. When I actually used to work on the shop, I used to say oftentimes that we as a rule, we just don't really give it the appreciation that it deserves. We spend many, many dollars on cylinder honing, the equipment to measure cylinders, gauging tooling, process studies, and then valve guides will say, man, ream it and call it good. People will just stick a valve in a guide and kind of do a little rattle check, and call it good. And quite honestly, we're doing all of ourselves a disservice by not really thinking about how important sizing, surface finish, all of the controls that we would worry about on cylinder bores really relate to a guide itself as well. So those points are guiding the valve throughout the entire service life of the engine while, maintaining coaxiality between the valve and the seat, or, we always say concentricity or eccentricity. The valve guide does do a percentage of cooling the valve as well. So the guide is also somewhat sacrificial, because in an ideal situation, you don't want your valve stem wearing. I know if we were requalifying stems, we do measure for wear and so forth, but we do expect the guide to live for the duration of the engine, but we also expect it not to wear out the valve stem. So, it's got some unique challenges. Most of the significant loads on the valve guide are thermal loads due to combustion. Ideally, 75% of the heat is transferred via the valve face to seat contact. That still means that the balance is going to go up the valve stem, be transferred via the guide, via the springs, retainer, and the other components that keep that assembly whole. Mechanical loads and forces on the valve stem, in the fact that you have a rocker arm, the ratio has an impact. Other things that are going to factor into the contact between the stem and the valve guide itself are, rotational forces of, most valves, unless you're in like LP or CNG applications where you sometimes lock the retainers and you stop the rotation. But in most cases, valves are rotating and they're going to be in contact with the guide. So that's, again, more opportunity for wear of the guide. This illustration here just shows some of the operational forces that would, induce stresses on the guide and cause wear. Same thing here, just a different view. As of late, especially in automotive, not so much diesel, but automotive, you see a lot of bucket adjusters have come back, and that does take some of that rocker ratio wear out, but valves are still rotating. You're still now with the high power per displacement, we're inducing a lot of heat into the component, so that really challenges the valve to get the heat out through the seat and so forth, and the valve guide is going to see more of that temperature. So valve guides must have some lubrication between the stem and the ID of the guide to resist scuffing. The amount of lubrication cannot be so large that it enters the combustion chamber and causes oil consumption. So what ways does oil enter the valve guides? Gravity, of course. That should be regulated or controlled by properly functioning valve stem seals. Valve movement. So valves are a reciprocating component. So the fact that they're stroking up and down and they're going to be in contact with the oil that's above and below the seal, again, we're looking for that seal to function properly to help regulate that, but that is a means of how oil is going to get into the guide. A V-type engine is going to have an impact on oil intrusion into the valve guides, overhead cams, things of that nature. Many of the overhead cams are absolutely flooded on the top end, so the seals are underneath of the volume of oil. So if they're not working, then it's going to be more oil entering the guide in the combustion chamber. And race engines, so if you're running an engine that's on a high banked oval, you're going to have a different amount of oil on one bank's guides than you are on the other bank's guides. And then pressure differential. Used to, we talked about this more in the diesel world because there were more supercharged, turbocharged engines that were in, the common public use. But now with the change that we've seen that nearly all gas engines are turbocharged as well, we are seeing situations where you go from vacuum to boost on both intake and the exhaust. And then we have lubrication that can be manufactured into the guide. It's very common in powdered metal that, we understand that there's lubrication manufactured into the guide, but, the graphite in cast iron is also lubrication, and that technology's been around forever. And just to speak to that a little bit, powdered metal technology has been around for, thousands of years. Platinum is actually falls into that realm. So it's not new technology by any means. It's not even new technology in cylinder heads, but it's something that, there's not everybody is making powdered metal guides that are going into the aftermarket to replace the guide that was there initially, in the cylinder head. So that, again, that's what brings up some of this subject matter anyway. So if you take a look at the images here, hopefully you can see those well enough. Valve guides of powdered metal materials, the center pores are filled with oil to provide additional lubrication. Under thermal load, this oil escapes from the valve guide, and as it cools down, it actually will pull that lubrication back into those open pores. So it's not so much that it's a porosity leak path that oil within the engine is going to leak into the guide. It's basically that those pores are going to be a point at which they can secrete the oil and store the oil. So here's kind of a flow chart of the cast iron valve guides. It's pretty standard. Anybody that's looked at this could be true of sleeves or something as well, but usually they're made in a rod. So a casting, and then they'll turn the blanks, pre-drilling, typically your heat treatment, centerless grinding, and then finishing the ID to the close diameter, machining of the endings. Machining of the valve guide endings can be for multiple reasons. Maybe you're making a place that's a receiver for the valve stem seal. Maybe it's just shape and distance, because of protection from the spring type and the retainer and so forth. And then, the inspection process inspections. Some pretty standard iron materials. So if you look at just gray cast iron on the left or a heat treated iron on the right, when I speak to heat treating, sometimes the whole guide is treated, and in some cases the IDs are in induction hardened. Usually some of the larger heavy duty guides, you'll see that. So powder metal materials, a lot of folks that do powder metal products, they always talk about it's kind of like the cake mix. When you're alloying metals, you don't get to see so much that you mix the components. Everything gets melted down, and you don't see it as like a recipe. But a lot of people refer to powdered metal technology. It's like making a cake or something. A little of this component, a little of that component. You see all these dry components or substrates that are mixed with some paraffin, and then they press it to a shape, and then they go through a sintering oven, and then they go through a oil impregnation where they actually load the pores. It's a vacuum impregnation process to pre-lube. And then there's also dry lubricants as well that can be put into the powder metal product that you can't necessarily do the same. Again, I mentioned, graphite in the iron. You can cast the iron with molybdenum and other things of that nature. But as far as like the oil impregnation, best of my knowledge, there's no practice of that in cast iron guides. We move on to the OD centerless grinding, the head turning again, making the shapes for stem seals or clearance or whatever the case may be, and then inspection. Okay, so if you look at in contrast between the iron, and actually I can try to, we'll go back. There's quite a difference here between what the PM products look like. Again, you can still see the individual components separately that you cannot see from alloyed casting. So, you know, there's still cast iron materials that are being utilized at the OEs. So I'm not here to take anything away from iron. I'm here more so to, again, just, you know, it's about the conversation. Hey, there's a lot of powder metal out there, but I can't necessarily buy powder metal. And we at MALA are actually working more toward trying to make some offerings of our powder metal products to the aftermarket. We do a lot of this stuff OE, but it's not been shared on the aftermarket side. So that's actually a project drive right now to actually do some of that. So this is just a bit of a comparison where you can see that you can take a PM product that will give you maybe potentially a wider range of applications that it can be ideal for. Again, we'll share this presentation with AERA, and anybody can request it and take a better look at these graphs. I know it's hard to do in such a short amount of time when we're doing a presentation. Some of the challenges with PM in my personal experience have been we just don't understand it enough to pick the right tool. So if you take a look at iron, it leaves you a lot of opportunities or options. High-speed steel reamers have been effective for many years, depending on the amount of stock removal that you're needing to do. Coated reamers, same steel, you know, high-speed steel, but with the, say, 10 coating or PVD or something like that, and they actually even get better life. So again, very effective. The multi-fluted carbide reamers are very effective, and it's all price driven. So, you know, if you have a few guides to do, you're probably going to go with a high-speed steel with iron. As that volume increases, then you look at coatings, and you look at carbide reamers, and guide honing as a primary or secondary process is effective. Sometimes single pass tooling is used to improve surface finish, geometry, even things like roller burnishing, or there's companies that have what looks like a roller burnisher, but it has it's kind of faceted. You know, the mandrel looks like a stop sign, and the rolls will actually, they call it bearingizers, and will kind of like shot ping the surface. So it's the motivation is not related to control size as it is to improve surface finish. When we talk about sizing of PM guides, though, it's typically, you're not going to be effective trying to use a high-speed steel reamer. You need to create a chip, so you need some depth of cut. So that tool is not really ideal for PM. So you're going to be looking at a multi-fluted carbide reamer or PCD. The OEs, that's typically what they're doing. They're using polycrystalline diamond. In the aftermarket, we've become pretty familiar with that term because that's what most people will mill aluminum castings with. The aluminum doesn't want to stick to the insert, leaves a nice surface finish, and you don't have to use oil or things of that nature to yield that surface finish. Cost is higher than CBN, but it does work well. But again, this is also a nice operational method, if you're, in a machining center and reaming the guides, PCD is a great option. So ideal stock removal is 10 to 20 thousandths. I know in the aftermarket, the use of oversized valve stems, anywhere from 3 to 15 thousandths in dimension. A lot of the stuff with smaller stem dimensions, they're going, choosing to go like 8 thousandths oversized. So this puts you pretty close to that. So I think that's an effective chip load to make sure that the reamer will work properly. Chip load is important because you don't want to smear the material. So you don't want to, cover those porosities and make the guide not be able to, provide the dry lubricants and or the basically sweating of the oil. Honing may cause smearing, so there's vitrified abrasives that do cut very freely. They're very sharp. You got silicon carbide, aluminum oxide, things of that nature. They do cut very free. One of the downsides to diamond is the shape. It doesn't cut quite as freely, but CBN has a very sharp shape, and that may be effective, but there's not been any process at the OE level that's been used to validate that at this time. So that is something that's been discussed, and I know there's some equipment and tooling manufacturers that are investigating that. So more to come on that. Again, I'm not really to say, in a perfect world for a part manufacturer, we don't want to see anybody resize guides, right? We would want to see everybody put all new guides in and buy all new valves, but that's not the reality of it. So, there are definitely some other issues that come with trying to get guides out of heads and that do not want to come out. I can remember some dealings with Duramax heads where you nearly destroy the cylinder head just to try to remove the valve guide. So, that's where some of these oversized stems and things of that nature come in. So again, I'm, speaking from a standpoint of, hey, I don't know of anything that is proven with CBN honing, but I know it's being looked at. So, you guys just keep your eyes and ears open and be looking around for all the guys out in the super abrasives of the world and honing and so forth, and maybe they've got some things in the wings that can help improve that. Ideal surface roughness, and again, it can be higher than this. I've personally never reamed powder metal valve guides and see them get any higher than about 10 or 12 RA micro inch, or 0.2 to 0.25 micrometer. But again, this is ideal surface finish, is about 8 to 10 RA micro inch. If you get too smooth, it could be an indicator that you're smearing over the porosities, because when you're checking surface roughness, we still, the profilometer doesn't distinguish a porosity from, a peak or a valley. It's about, that stylus travels up and down. So if you may get a strange number and you need to evaluate it closer. But if it gets too smooth, I would definitely be, trying to cross-section that guide and take a look at it and see if you have, smeared material and that you've lost your porosities. If you get too rough, maybe you got a chip in an insert, or you have high peak to valleys or something like that. But again, my experience is it's been very difficult to see surface finish get very high on PM guides. I've seen it's pretty standard, and seen some specifications that say like a maximum of 115 RA on the ID of a cast iron guide. And, ideally, I think they typically run in the neighborhood of 30 to 50 would be optimum. but I've seen it, published up to 115. Um, I have never seen I've never seen a PM guide, even above 30 that was messed up. So why are so many valve guides PM guides now in modern engines? Well, cost, as with many PM parts, there's less machining. So if you have a near net part, and you have less time in machining, you're definitely going to cut some cost out. If you take a look at probably some of the earliest parts that we experienced in the aftermarket, trickling down to us in the PM world, was gears, then connecting rods, and then with aluminum heads, PM valve seats. And then we went through the phases that we started to see the powdered metal lobes on the assembled camshafts. So basically, they slip the lobe over a steel cam. They would run a burnishing ball through the ID of the cam and lock the lobe to the camshaft. And, there are just tons and tons of parts. Bridges and locators for, rocker stands, and the trunnion or the pivot of the rocker itself. So just tons and tons of PM products. And again, it's just, it's cut cost. But that being said, PM, there's so many unique materials that can be mixed, to reduce wear of the guide. Maybe it's reduce wear of the fulcrum point or the trunnion of a rocker. We just have a lot of opportunities to do some unique things there. We can induction harden like the gears are at the tip. We can put cobalt or tungsten, whatever in the guide and make it wear very, very well against hard surfaces. So, should all guides be converted to PM? I don't want to say that. There's always opportunity to take a look at it, but you should really, really evaluate the whole assembly. So if you have a guide or a valve that you've used for many years, and I'm just throwing some numbers out there, but say if it's a 21-2N valve and it's got a wafer tip on it, and it's always run in a bronze guide, and then you say I want to throw this PM material at it, and the stainless steel gives you good ductility. It gives you, the valve will bend before it breaks usually, and those steels are somewhat soft in actuality. So if you select a valve guide that's got some really hard particles in it, all of a sudden you start to have stem wear that you didn't see before. So you don't want to take these quantum leaps and say, I'm just going to start changing these things. You need to, investigate, evaluate, and make that determination. Hey, can I use a PM guide for this application? Maybe there'd be some benefit from, having the dry lubricants or infiltrated lubricants or something that could help me out. But you just don't want to, jump too quickly and then create other issues elsewhere. So I'm not going to say that, hey, walk away from cast iron guides and go to all PM. That's, not what we're here to, the message we're here to promote. All right. And with that, again, like I said, I just wanted to do kind of a high level coverage of this topic. And, if there's any questions, there's my information. I know Rob has got some time slated in here. We can have some questions while I'm online, or if it's something, more specific you'd want to send to me, there's my email and my phone number. So Chuck Lynch at us.mala.com, and that's chuck.lynch at us.mala.com, and 248-226-0438 is my work cell. And so I'll stand by and see if there's any questions we can answer.
Super. Thanks, Chuck. No, really good presentation. Bit of an eye-opener, as to, what, especially machining wise, some of our tooling that maybe we have in the shop, we're not going to be able to rely on when we see these new materials. So really good eye opener. And again, we appreciate your time as well as for Mala being able to free you up to do this for us. So there are a couple questions that have come in. And so one person's asked, can you install bronze liners in a powdered metal guide?
The challenge with that, because people will put bronze guide liners everywhere. The tools iron machines pretty easily, so to cut a cast iron guide to put a liner in is not going to be that difficult. You have to have know that you have the correct percentage of wall thickness to length when they design these guides. So to put that guide liner in there, you may actually impact the integrity of the guide, so it may fall apart on you. And then typically they're hard to machine, so the cost of the reamer to put guide liners in may outweigh the cost of trying to replace it. Again, as I mentioned earlier, they can be difficult to replace, but those would be some of the challenges. So with the materials of the PM guides, I know they can get the ratio of guide wall to length reduced. And I actually have some more information on that I could share if anyone would be interested.
Okay, all right. Another one's come in. Could you explain a carbide fluted reamer for powdered metal, or from a powdered metal reamer? What's the difference there, I think is what this gentleman's asking.
Okay, so when I'm referring to those, I'm going to kind of throw a name out. Like there's Hart RTS cutting tools. I know Goodson offers some high-speed steel blanks that have carbide flutes that have been brazed into the reamer, and then they have different, lead angles and so forth. They'll have, say, a pilot diameter and then the oversized dimension or whatever. The high-speed steel reamers have, again, they just typically, because you're not taking much material, the chip load is not enough that they work very well on the PM. The hard particles at the surface tend to make it just kind of gall. I've had, terrible success trying to ream those, but the carbide reamer, does actually effectively cut that. I hope that answers it. But again, it's just a steel body that's had brazed in carbide inserts to a specific diameter.
Okay, all right. And just the same gentleman's asked, do you know who supplies a carbide fluted reamer?
Yeah, again, RTS cutting tools, Hart. I know that, Goodson and, probably maybe even Silver Seal. I don't know as far as distributors, but, there are manufacturers out there making those reamers.
Okay.
And we could exchange some emails. I can do some more research. We probably have a line on, even PCD reamers.
Okay. Another gentleman's asked, what is the hardness factor of a powdered metal guide compared to most of the cast iron guides used for diesel applications?
Okay, so anyone that's ever used powdered metal seats so apparent hardness and working hardness are different. So if you were to try to measure the hardness, say, HRB, this thing, it may come in at 25 or 30, but once it actually activates and it's running, it's going to have an apparent hardness of, say, 45 Rockwell. So it's kind of difficult to say, okay, this is the exact number. Again, that's just the nature of some of the powdered metal products in the manufacturing and then how they react to temperature. Because in another component is going to be the hard particles that you can have at the surface, So we all know that a piece of carbide is about 62 Rockwell. Well, when you can load that valve guide up with a bunch of carbide particles that are going to be the effective working surface, you could say that guide is nearly 60 Rockwell, even though, again, apparent hardness, because you would crush in the areas between those hard particles, and it's going to show as very soft. So hopefully that explains it.
Okay. So you mentioned there are many powdered metal material options. Are there many iron alloys?
There can be. You take a look over the years, many of the manufacturers have had, for instance, a sought after high nickel bow tie block, so that probably wasn't an SAE standard that was very common. They came up with a material that, hey, for this application, we're going to throw a lot of nickel at it, give it some more ductility. Cast iron's usually about as, has the flexibility of a Jolly Rancher, so let's give this block more opportunity to be able to flex because it's a race engine application. So the answer could be yes, but actually most people stick to just a few different alloys. So they improve the alloys maybe for lubrication, something that takes hardening better. I mentioned the 21/4 inch stainless steel valve. Well, the reason those have a wafer tip on it because you can't harden it in the valve tip area. So that particular steel doesn't like to be hardened. So the same can be true. Hey, how effective can you harden this particular iron as opposed to this iron? But so that we're not all willy-nilly, we've kind of settled in on just a few different alloys. Powdered metal seems to be a bit different. They can tend to be more application specific, and that's why I was cautioning about, hey, let's just pick a powdered metal guide and say I'm going to run this guide, and all of a sudden it starts to wear your valve stem out. So definitely more powdered metal variation than there would be in your iron alloy variation.
All right. Another question here for you. Should powdered metal guides be reamed wet or dry?
So, perfect world, they're reamed in a machining center and they're flooded with coolant. The coolant can help keep all those hard particles away from the shank of the reamer and causing the reamer to wear and then causing scratches and so forth in the surface finish. Typically, any time that you're trying to machine with flooded coolant, a lot of that's what you're actually after. It does keep the tooling cool, reduces friction, but it also keeps all the trash away so that you don't get, some ancillary effect like, scratches in a bore or material impacting into the parent surface. And again, as stated, wearing out the tool itself as the particles are flying around at it and wearing the shank dimension, things of that nature.
All right. Okay, we've got time basically for one more question, so we've got one more, and then we'll let everybody get on with their day. So we appreciate Chuck's time, and like I say, we appreciate everybody joining us, and we'll let you get on with your day. But one more question here for you, Chuck. So do you need to lubricate the valves prior to installing in powdered metal? If they, you mentioned they have some lubricant in the material already, so is that important?
Yeah, that's a good question. And I've seen a post earlier about what people are using to build engines with lubrications and whatnot. And, best advice would be, hey, what's the rated oil for that particular engine, and use that as your lubrication. But yeah, definitely take the opportunity to get some lubrication in the guide. The dry lubricants and the heat activated lubricants, are there. It's better than nothing, but hey, take advantage of getting some lubrication on your components and without making a mess.
Okay, super. So for those of you that are going to be at TriStar for the regional coming up on Friday, Chuck will be there. He'll have a booth there as well as doing a presentation. So by all means, if you have any questions for Chuck, feel free to go up to him and introduce yourself and ask away. So Chuck, we really do appreciate your time. I know you're a busy guy, so thanks again, and great presentation, and we hope you enjoy the rest of your day. And for now, I'm going to bring up Amanda, and she's just going to go through and we'll finish off a few little housekeeping slides for you.
All right, thank you.
Thanks, Chuck.
All right, just a couple things really quick. First off, tomorrow you will get a follow-up email which will contain a link to the recording of today's webinar. That is yours to use as you wish. You can share it with staff and coworkers or watch it again at your convenience. Also, when you leave the webinar today, there will be a short survey. Please take a moment and fill that out. Let us know how we're doing, if you have any additional questions for Chuck or anything else you'd like to see us do down the road. And lastly, you will see our contact information is there. The AERA line is 815-526-7600, and that will get you to any of us on staff. And then you'll also see my email and Rob's is there along with Steve and Karen. So a few different points of contact for you, or you can always just reply to any emails about this webinar and I will get those as well. So thank you again, everybody, for your time today. We truly appreciate it, and we hope you have a great rest of your day.